Discover how to design scalable feature store architecture for efficient handling of large data volumes in machine learning workflows. Learn key components and best practices to build robust systems.
Welcome to today's video on how to design scalable feature store architecture. Did you know that 90% of data scientists struggle with feature management? In the world of machine learning, feature stores play a pivotal role in managing and serving features consistently and efficiently to your ML models. They are the backbone that supports the scalability of data processing and ensures the reliability of machine learning workflows. In this video, we'll dive deep into understanding how to design a scalable feature store architecture, the key components involved, and best practices to handle large volumes of data effectively. Let's get started. Feature stores serve as centralized repositories for storing, managing, and serving machine learning features consistently across training and serving environments. By integrating seamlessly into ML pipelines, they enable teams to reuse features, maintain data consistency, and streamline model training and deployment processes. Imagine a scenario where every new model requires a new set of features. This is not only inefficient but also error-prone. Feature stores mitigate this by providing a structured way to store features that can be reused, updated, and monitored over time. In this section, we'll explore how feature stores integrate into ML pipelines and discuss real-world examples of their benefits.
Designing a scalable feature store architecture involves understanding its core components. At its heart, a feature store consists of a feature registry, a data storage solution, and a serving layer. The feature registry keeps track of feature metadata, including definitions, types, and versions. The data storage solution must be robust enough to handle high throughput and low latency operations. Feature ingestion and transformation pipelines are crucial for processing raw data into features that your models can consume. We'll discuss how to manage these components effectively, ensuring scalability and reliability in your ML workflows. Data ingestion and transformation are critical stages in feature store operations. The ability to efficiently ingest data from various sources, whether in real-time or batch modes, directly impacts the performance and reliability of your ML models. Real-time processing allows for immediate feature updates, while batch processing is suitable for less time-sensitive data. Transforming raw data into usable features involves cleaning, normalizing, and aggregating data. In this block, we'll cover best practices for setting up data ingestion and transformation pipelines and ensuring the integrity and quality of your data. Metadata management and feature versioning are often overlooked but are vital components of a robust feature store architecture. Metadata provides essential information about each feature, including its source, type, and lineage. Versioning allows data scientists to track changes and updates to features over time, ensuring models remain consistent and reliable even as data evolves. This block will delve into effective strategies for managing metadata and implementing feature versioning, ensuring your feature store supports continuous model improvement without breaking existing workflows. Data consistency and quality are paramount for the reliability of machine learning models. Inconsistent or poor quality data can lead to inaccurate model predictions and compromised results. Ensuring data consistency involves implementing robust validation and quality checks at every stage of the feature pipeline. Automated monitoring tools can help detect anomalies and data drift, allowing you to take corrective actions promptly. We'll explore these challenges and solutions, providing you with the knowledge to maintain high data standards in your feature store.
Optimizing the storage and retrieval of features is critical for the performance of a feature store. The choice of storage solutions directly impacts the speed and cost of feature operations. Caching strategies can significantly enhance retrieval times, crucial for real-time applications. Balancing cost and performance involves choosing the right storage technologies, such as in-memory databases, distributed file systems, or cloud storage services. In this block, we'll discuss how to optimize storage and retrieval processes, ensuring your feature store supports scalable and efficient ML operations. Integrating a feature store into existing data infrastructure can be challenging but is essential for maximizing its benefits. Ensuring compatibility with current systems involves using flexible data integration techniques, ensuring seamless data flow across platforms. Leveraging cloud services can simplify integration, offering scalable and flexible solutions. In this section, we'll explore strategies to effectively integrate feature stores with your existing data infrastructure, supported by case studies of successful implementations. Designing a feature store that is both scalable and robust involves adhering to best practices that ensure efficiency and reliability. Key design principles include ensuring feature reusability, implementing security measures to protect sensitive data, and adopting industry standards for interoperability. Monitoring and maintenance strategies are also crucial for long-term success. In this block, We'll cover these best practices in detail, providing you with actionable insights to enhance your feature store architecture.
Nothing illustrates the power of feature stores better than real-world examples. Several leading companies have successfully implemented scalable feature stores, transforming their ML workflows and driving business performance. This section will present case studies, highlighting challenges faced, solutions implemented, and the impact on business outcomes. We'll also discuss lessons learned and future trends in feature store development, providing you with a comprehensive understanding of real-world applications. We've covered a lot about designing scalable feature store architecture. From understanding their role in ML pipelines to exploring best practices and real-world examples, you're now equipped with the knowledge to start building your own robust system. A well-designed feature store can vastly improve your data handling capabilities, streamline ML workflows, and enhance overall performance. We encourage you to start implementing these strategies in your projects. Don't forget to like, comment, and subscribe for more content on machine learning and data architecture. Let us know what topics you'd like to see next.